Hello everyone, welcome back. So this time we're learning about the method of sections. And you're like, okay, method of sections. We learned about method of joints. Remember that? This is different, but it's not going to be terrible. Don't worry about it. You worry about it a little bit. So what is method of sections and why do we care about it? Well, first let's look at some applications where it might be very helpful. For example, there are a billion joints and moments in these things. Okay, there's just so many. And if I use our current method and I'm like, okay, well, I'm going to build it from here, and all I care about is the force, through this member way up here, I've got an issue because I don't want to work all the way through all of these to finally make it there. That'd be painful. Method sections will allow us to jump through those hoops and get past all those various steps the method of joints would have. We can just jump straight to where we want. It's a little bit harder in some ways, but it can also simplify things if you only care about certain members or if you have a very complex structure. Complex structure where you don't care about every single member. So having that other method is going to be helpful. How does method sections work? Well, method sections works by cutting things. We cut it into a section, and then we keep only one section for the other one. One appears, the other one disappears. And wherever we cut, we replace it with a force. So if I cut it, tensile stays tensile. If I cut it, compressive stays compressive. Okay? Because all these things only have internal forces, and they only have those forces directly along the line of the truss element. So once I cut it, I choose a section to keep. I can choose either one. And I get two free body diagrams, one for each section. So I can cut it actually several different ways if I need to and get a bunch of different free body diagrams. Usually not necessary. Usually one will be enough or two will be enough. Or I might use method of joints and method of sections to kind of get everything together. Wherever I cut, I replace, I put a little force that was going along that originally. Once again, if you don't know any better, draw the lines going away from the pole. That's tension. And just assume that, and if you get a negative sign, you can fix it. So with that, I can then solve. Now, since this has size, I get three equations. Sum of forces in the x, the y, and sum of the moments about a point I choose. Spoiler alert, find a point that has a bunch of lines of action going through it. Because then, they don't cause a moment around that point. And you can solve things very simply. Remember, try to make it simple. It makes things a lot easier. Okay, so once again, I always seem to jump ahead, but this happens. As another note, you can try to, if it's possible, solve for the support reactions before you start cutting things. You can just use one free body diagram for the entire structure as it is, solve for the support reactions, and then move on to solving for the individual pieces. It can be helpful. Okay. Now, as I said before, we drew all the free body diagram of the pieces we've cut. We add in all the forces we can, and then we solve. If your answer is positive, then it's as you drew it. If you drew the line away from the member, that means you were putting it in tension, and positive means it was in tension. If you get a negative number, it was in compression. So my advice is, even though you see right here that they are drawing this as in compression, draw everything as tension and let those negative signs tell you what's actually in compression. And finally, you apply the equations of equilibrium. And usually, in most cases, it's possible to write equations such that you only have one unknown to solve for. As you've seen in the past, just a little bit of thought and planning can really make things a lot easier on you. So make sure you do that. Oh, I jumped ahead too far. Like finding this point C was super helpful. If a force's line of action goes through a point, it does not cause a moment about that point. Remember that helps you a lot. So with that, I'll stop here. Method sections might not make much sense yet. But take some time, watch the next examples, and see if it treats you well, okay? I'll see all of you next time. Bye-bye.